So we're dealing with moles. That's what we've been dealing with. Well, we dealt with yesterday. All right. We're given a certain number of moles. We want to know the certain number of moles produced. The reality is you're not always given moles. Okay. So what if they're not already in moles? All right. Remember, we talked quickly yesterday about the moles bridge, which is this bit right here, where you convert from moles of one thing to moles of something else. The moles bridge. So I had to give it to you in moles, but you don't always get moles. Usually when you weigh stuff out, well, not usually, all the time when you weigh stuff out in the prep room is you're weighing it in grams, okay? So you're given a mass, which you then convert to moles, which then you convert to the new moles, which then you convert to either the mass of your unknown, like how much you're going to get in grams, the volume, for which would be in liters, or if you really wanted it, you could do molecules. That'd be a kind of a strange one to do, but you could do it. All right. And we've done all this stuff in chapter 3 or whatever, the mole chapters. Basically, we did these conversions. All right. So I'm not going to go through that because I don't think it helps us. One thing I want to talk about is when you see volume, all right, doesn't always mean a gas. Volume is also liquids, right? So you have to be careful here, all right? When it's volume, you have to look to see if you're using a gas. If it's gas, then you use 22.4 liters per mole. That's the volume of 1 mole of gas, okay? Only gases. So you have to look at this is why the equation is important. Look at, or the reaction, I guess. I keep saying equation, it's a reaction. Look at reaction to see if gas is involved. And if the gas is involved, then you use 22.4 liters. Okay? So just be careful about that. And then for solutions, i.e. aqueous, we use molarity. What is the formula for molarity? Moles per liter. So molarity, capital M, is moles per liter. So we're using everything that we've learned so far, or we're going to. Okay? And remember, molarity is also representative of concentration, which we represent by square brackets. Okay? So concentration is the molarity, which is moles per liter. All right. I like the second sort of flow chart a little better because it kind of lists the steps. Okay. Can I? No? Okay, one sec. We're going to use all this stuff. Like, so if you don't write that down, that's okay. Are we good? Okay. So this one, it lists the nice steps for you. So the first step in every case, you need a balanced equation. If you don't have a balanced equation, you can't do anything. Okay? On a test or a quiz, well, a test, what I would do is, because the balanced equation is so important, I would give you a choice. I haven't thought this through, but I do it in math sometimes. If you mess up like the first step, the rest of the problem is wrecked. So I would give you a choice of, you can balance it yourself and then just go on, or you can, and I'm putting this in quotes, buy the balanced equation from me for 1 mark. Okay, but we'll talk about this when we get to a test or a quiz. So for example, if the quiz is if that question's out of 4 marks, and you asked me for the balanced equation, all right, for you, the highest mark you could get would be 3 out of 4. Does that make sense? Okay, but we can talk about that later on. Yeah. Bonus is the bonus. Yeah, I gotta do everything. Oh, well, yeah, you could add it on to your mark at the end. So yeah, theoretically. Yeah. Okay, so first one, balance the equation. Second step is you need to know moles. Everything is going to be moles. So that's where we're going to use our molar mass. So if you look, well, here it is right here. If you're given grams, so if you're given grams, you're going to use molar mass, all right, which is the thing you calculate from the periodic table. If you're given volume of gas, all right, you're going to use, this is the molar volume, that's 22.4 liters because we're talking about gases. Oops. Moles goes right to it. And if you're given the number of particles, then you're going to use Avogadro's number. What's Avogadro's number again? (23). 6.02 times 10 to the 23. Okay. I don't expect you to memorize this because I'm going to put it into a chart and it kind of just falls together. That's how I work it. And then this will give you moles, and then you use the coefficient. So this is the moles bridge essentially. And then you spit out your answer in molar mass for grams or volume or just moles or particles. Okay? So we're going to practice this right now. All right? Because this is like, I feel like this is overwhelming. I don't memorize this. If you want to, you can. I do not memorize this. All right? I just kind of let the math take care of itself. So here we go. How many grams of potassium chloride are produced if 25 grams of potassium chlorate decompose? So here's our chemical reaction. 2ClO3 goes to 2 potassium chlorides and 3 oxygens. Okay. We're given 25 grams of potassium chlorate, which is KClO3. So you're given 20. Oh, step one's already done for us, right? Because we have the balanced equation. So we don't have to do that. So we have 25 grams of potassium chloride. All right. Do I like things in grams? No, you always want it in moles. So we got to convert our grams to moles. So to convert grams to moles, what do we need? You need the molar mass. You got to pull out your periodic table. Do you all have your data booklets? You need your data booklets for this chapter. And you're going to calculate the molar mass of potassium chlorate, KClO3, this one right here. And I'm going to let you do that because I want you to practice it. Do you have your data booklet, Mason? You do not. Sorry, what'd you get? 122.6? 0.7? Sounds good to me. Oh, sorry. I thought you said 7. 122.6 grams per mole. Does everybody else agree with that? Or are you just going to nod your heads and be like, yep, Carter got it. Okay. All right. So how do I write that in the next box here? What goes in the top one? What goes in the bottom one? Mm-hmm. We wanted the grams to cancel, so you put them in the bottom. And we know those units cancel. So now we have moles of KClO3. Now it's like the problems we did yesterday or at the beginning of class today. We're given number of moles. I want to know grams of potassium chloride. How many grams of this? But now we're at the stage we have moles, right? So when you have moles of this, I would try to figure out the moles of this. So that's the moles bridge thing that you're crossing. Okay? So what's the ratio using the equation? Moles of KClO3 to moles KCl. It's 2 to 2. So 2 moles KClO3 produces 2 moles of KCl. So now the moles of KCl3 are gone. And we have moles of KCl. Is everybody with me? What do I want my answer in? Grams. They want the answer in grams of potassium chloride. So to go from moles to grams, what do I need? Molar mass, right? So I need to know what is the mass of potassium chloride, KCl. What's the molar mass of KCl? Is everybody waiting for Carter to do it? All right, 74.6. So potassium chloride has a molar mass of 74.6 grams per mole. Okay, what goes in the next box? What goes in the top? What goes in the bottom? Yeah. So moles go in the bottom because I want the moles to cancel. So 1 mole of KCl weighs 74.6 grams of KCl. Or it is 74.6 grams of KCl. So your moles of KCl cancel. The only units left are grams of KCl. What do you do to everything in the top? Multiply, right? So 25 times 1 times 2 times 74.6. I have no idea what that is. We're going to do it in 2 steps here. Just multiply the top for me, please. What do you get for the top? Sorry? 3,730 grams of KCl divided by, and then you're going to multiply everything in the bottom. 122.6 times 2 times 1 should be 244, 255.2. Oh, 245. That makes more sense. Yeah. 245.2. That doesn't have units. If you divide those, what do you get? 15 point what? Yeah, but give me. Oh, okay. But give me the decimals. Just that's good. 15.21 grams of KCl. How many sig figs should your answer have? Why? Because there's 2 in the original, right? So it's just 15 grams of KCl. Okay? Do we feel comfortable with that? It's always whatever you're given, convert to moles, and then go across the mole bridge, so moles of whatever you're asked for, and then convert that to whatever they want, grams, liters, blah, blah, blah. We're going to do one more, and I'll give you some practice, and then we'll move on to bigger ones. So, all right, volume. There we go. What volume of hydrogen is necessary to react with 5 liters of nitrogen to produce ammonia? Okay. As soon as you see volume, you have to ask yourself, are these gases or are they liquids? These are gases, right? Nitrogen and hydrogen are gases. So we're dealing with gases. Okay. We're given 5. Is the equation balanced? That's what you have to ask yourself. It is balanced. So we've got 5.00 liters of nitrogen, N2. Do I want liters? What do we want? We want moles. We're dealing with gases. What is the conversion, or what's the units for gas conversions? Yes. So as soon as you see, because they say STP, which means it's 22.4 liters per mole for gases. Okay, what goes in the next top box in this one right here? Moles, exactly. So one mole of N2 is 22.4 liters of N2. So now our N2s are canceled, our liters of N2s. We have moles of N2. Now you're going across the bridge, right? So we need to get moles of N2. We're trying to figure out what volume of hydrogen, right? So hydrogen. So now we're using the ratio of the equation. I'm going to need hydrogen up there. I'm going to need N2 down there. What numbers go where? Yeah. So it's 3 moles of H2 reacts with 1 mole of N2. All right. And now I have moles of H2. So what's the final step? Because they want to know what volume. Volume is in liters. So what do I put in the next step? 22.4, because we're going from moles to liters. So it's going to be 22.4 liters of H2 for every mole of H2. Oops. So those units cancel. And then you're going to tell me the answer. It actually worked out nicely. Yep. 15. How many sig figs? 3 sig figs, right? Yes? Liters of H2. Okay. Yep. Yeah, because you can see the 22.4 is actually cancel, right? Yeah. It that won't work out. Yeah. Okay. I would like you, before we do the next bit, to do, if you go to Hebden, so you're gonna need your Hebdens here, peoples. Number, hang on, let me pause this. Here we go. We are burning propane, C3H8. How much water? So, what type of reaction is this? Combustion reaction, right? Because we're burning a hydrocarbon. So, C3H8, I should write this in. C3H8 plus, what do you need to burn things? Oxygen, O2. What is always the product of a combustion reaction? CO2 and water. All right. Your job is to balance it. Go. Please. that it? 1534. Okay. So now we got a balanced reaction. They want to know how much water is produced if the reaction produces 50 liters of CO2. So what we start with is 50 liters of CO2, and that should actually be in 50.0. Okay, 50.0 liters of CO2. All right. Do I want liters of CO2? No, you do not. We want moles. Is CO2 a gas? It is. So what is the conversion factor we're using? 22.4, right? So 22.4 liters of CO2 is 1 mole of CO2. Okay. Now we have moles of CO2. So now we're going to cross the mole bridge. So that's where you use the ratios in the equation. We need to get it into water. What's the relationship of moles of CO2 and water? 3 and 4. So that means for every 3 moles of CO2 produced, you get 4 moles of water. All right. So now we got, if you check our units, gone, 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 gone. We got moles of water. I don't want moles of water. I want, what am I asking for? Mass, which is in grams. So what do I need? Molar mass of water. What's the molar mass of water? 18 grams is the molar mass of water. So 1 mole of water is 18 grams. 18.0 grams. That's what it should be. 18.0 grams of water. All right. So you check all the units canceled that are supposed to cancel. We're left with grams of water. You're going to tell me the answer, please. What's the answer? 53.6? That, yeah. 53.6 grams of water. And we want 3 sig figs because that matches up with what we have. Are we good? All right, we got one more, and then we are done. Okay. Oh, we got 2 more, actually. Let's not worry about this one. Let's come back. We can come back to that one. Let's look at this bottom one. I want to do molecules. So we got H2SO4 plus 2 sodium hydroxides go to water and sodium sulfate. What type of reaction is this, by the way? Sorry? It's an acid-base neutralization, right? Double replacement, but it's a special case of double replacement. It's the acid and the base. Okay. It's already balanced, so we don't have to worry about that. We're given 2 grams of sodium sulfate. 2 grams, 2.0 grams. I guess I should write that. Of sodium sulfate. Na2SO4. There we go. All right. All right. How many molecules of water? So I got to get sodium sulfate from grams to moles. So I need the molar mass. I'm just going to tell you the molar mass. Molar mass of sodium sulfate is 142.1. So that means we have 142.1 grams of sodium sulfate per mole of Na2SO4. All right. So we got the moles. Now we go across the mole bridge. So we got to use the ratio in the equation, and we're going from sodium sulfate to water. What's the ratio? It's 1 to 2. 1 mole of sodium sulfate is 2 moles of water. Okay. Now, they want molecules of water. I don't know why you would want molecules of water, but they want molecules of water. So, I got to get from moles to molecules, which involves what special number? Avogadro's, right? So that means then 1 mole of water, there are 6.02 times 10 to the 23 molecules of water. Okay. And then you're going to tell me the answer, please. Punching it in your calculator. What do we got? 1.7 times 10 to the 22. Molecules of water. And always check your units. We can see all the units cancel. Boom, 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 boom. That's pretty much it. Okay? That's about as complex as they'll get. All right? So, balance the equation. Start with whatever you're given, convert it to moles, go across the moles bridge. The moles bridge is always this part. That's not what I wanted. Is always this bit where you're using the ratio from the equation. All right, that's what the moles bridge is. Because then you're converting from moles of something you know to moles of something you want to know. And then it's just, do you want grams, liters, or molecules? All right. Finish 6, 7, and 8, please, from the book. There's only 10 minutes of class left. And that's it. Please practice because